Hello everyone, welcome to the video lecture series of eigenvalues and eigenvectors. In this video lecture, I am going to discuss how to find eigenvalues. Now, out of the traditional methods of finding eigenvalues, I am trying to classify the entire procedure into this three methods. One is direct solving method, using the formula of the characteristic equation. Third one is using the properties of the determinants. In this video lecture, I will be mainly focusing on method 1 and method 2. So let us see how to go by method 1. Let us take an example of this 2 cross 2 matrix for which we want to find eigenvalues. Okay, so to find eigenvalues, we need a characteristic equation which is given by this formula, that is determinant of A minus lambda I equal to 0. So how do we obtain this determinant of A minus lambda I? It's very easy. You just write this matrix in a determinant notation and subtract lambda from the diagonal values in the following manner. It will be, determinant notation is two vertical bars, and write the elements as they are, and you have to subtract lambda from the diagonal elements, that is 5 minus lambda and 2 minus lambda is what we will obtain. Simplify the determinant. On simplifying the determinant, we obtain 5 minus lambda times 2 minus lambda minus 4. Further simplifying, we obtain the quadratic equation lambda square minus 7 lambda plus 6 equals to 0. When we simplify this quadratic further, we obtain lambda minus 6 times lambda minus 1 as factors, and finally the roots are lambda equal to 6 and lambda equal to 1. So this value 1 and 6 are the eigenvalues of the matrix A. Okay. Now this is the method 1 by direct solving. Just take the equation, do the substitution, nothing else. Now let us go for using formula of characteristic equation. In my previous video lecture, I had given you the formula for a 2 cross 2 square matrix. The formula of the characteristic equation was lambda square minus trace of A times lambda plus determinant of A. Okay, and finally we know that determinant of A minus lambda equal to 0 is nothing but your characteristic equation. Okay, so now try to understand here. We can, by just observing the 2 cross 2 matrix, we can directly write the characteristic equation. Here the characteristic equation is this, lambda square minus 7 lambda plus 6 equals to 0. Now let us see how. Trace of A, this is the formula. So to find trace of A, you just have to add the diagonal values, 5 plus 2 which is 7. So substitute trace of A as 7. Determinant of this 2 cross 2 matrix is 5 into 2 is 10. 10 minus 4 if we do, it is 6. So this is the determinant 6. So this is your characteristic equation. Okay. And when we simplify this characteristic equation further, you will obviously obtain the same factors again. And finally, your answer will be lambda is equals to 6 and 1. So same procedure happens, but you just, instead of writing this determinant and everything, you can immediately write the characteristic equation, but the same steps remain for formula method also. Okay. So these are the two important steps according to me in solving. The first is the characteristic equation, in which you have the polynomial form of the characteristic equation, and this is the second form, that is lambda minus 6 into lambda minus 1 is the second form of the characteristic equation, where you can see the factors of the characteristic equation. Okay, So this is these two forms are very important, and we will see them in later concepts that are going to be used also. So similarly, you can find eigenvalues for this 2 cross 2 matrix using the same method. Okay, so this is for a 2 cross 2 matrix. Try finding for this matrix also, and let us now move on for a 3 cross 3 matrix by the same method 1 and method 2, how they will help you. So consider this example. This is a 3 cross 3 matrix. We are interested in finding the eigenvalues. So the method remains almost same. So first we have to find determinant A minus lambda I is equals to 0, as it is the characteristic equation. So what we have to do is you write the entire matrix in a determinant notation between two vertical bars and subtract lambda from the diagonal values of each of the element over here, and then you use the formula for the characteristic equation that was given to you in the first video lecture. It is as follows, that is lambda cube minus trace of A times lambda square plus m11 plus m22 m33 times lambda minus determinant A is equals to 0. Now how do we find trace A? Trace A is nothing but the total of the diagonal values. So 2 plus 1 minus 1 is going to be 2. So it's going to be lambda cube minus 2 lambda square. Okay, so this is what I have, lambda cube minus 2 lambda square. Now what about m11? M11 is obtained by deleting the first row, okay, and the first column. So this submatrix is left out in front of you. You take the determinant of this submatrix, that is 1, 3, 1, minus 1. When you take the determinant of this, you get is minus 1 minus 3. It is minus 4 is going to be the output over there. For M22, you have to delete the second row and the second column. So you obtain 2, 3, 1 and minus 1. So when you take the determinant of the remaining elements over there, you will get minus 2 minus 3 plus M33 is going to be obtained by deleting the third row and the third column. So it is this first 4 elements over here, and so it is 2 minus 2, 1, 1, and so the answer is going to be 4 over here again. Okay, and finally determinant of A is obtained by calculating the entire determinant by usual method, and finally you will obtain on simplification lambda cube minus 2 lambda square minus 5 lambda plus 6 is equals to 0. So this equation is your characteristic equation. Okay, now the LHS of this, that is lambda cube minus 2 lambda square minus 5 lambda plus 6. This part is known as characteristic polynomial, but when you equate it to 0, it is known as characteristic equation. This is a very minor difference, but it is very important. Now I need to solve this equation. You can use any higher advanced technique from algebra that you are aware to solve. I am going to use one very basic technique from school level, which you can be handy at this point. The result of that technique is here. Let p of x be a polynomial with real coefficients. Then we say a real number alpha is a root of the polynomial p of x if p of alpha is equals to 0. The hidden meaning in this is that x minus alpha is a factor of p of x. Over here in my question, I do not have a polynomial in x, but I have a polynomial in lambda. So finally what I have is lambda minus alpha as a factor I should be able to find. So I have to choose a number alpha which will help me to get my polynomial equal to 0. So just by trial and error we can do this method. And for example, just see, I'm taking lambda over here. I'm just putting lambda equal to 1 in this LHS part. So 1 minus 2 minus 5 plus 6. If I calculate the LHS, I get the answer is 0. Therefore, LHS is 0, RHS is also 0. Therefore, I see that this polynomial is boiling down to 0 and it is satisfying. That means lambda minus 1 is the factor of this polynomial over here. Okay. So once I obtain one factor lambda minus 1, I can obtain the remaining part of the polynomial by doing the division of the polynomials and obtain the remaining part. Okay. So you can try this method of a synthetic division also is allowed, or even you can try polynomial division method and go on solving the polynomial and get that. Okay. So finally, on solving by all the methods whichever you know, or by this method also, lambda minus 1, lambda plus 2 and lambda minus 3 equal to 0 are our factors, and I obtain that finally that lambda is equals to 1, 3 and minus 2 are the eigenvalues of matrix A. So this method also works right now for a 3 cross 3. I hope if for you calculations are allowed using calculators, then you can easily get the answer from the calculators. You need not use these techniques. But if no calculators are allowed, you are bound to use some advanced techniques of algebra that are available. So one of which this school level technique can help you at that time, but at trial and error you just need to work out very fast with these numbers. Okay, so having understood this technique, again over here observe that this equation number 1 and equation number 2. Equation number 1 is the polynomial format of your characteristic equation, and equation number 2 is the factor format of your characteristic equation. Both the formats are very important to us, so that's why I'm highlighting it with this red star, and they will be used ahead. Okay, so for your practice you can take this problem for yourself, that you can try to find eigenvalues of this matrix. Just find eigenvalues. Later on by my next video lecture, I will be able to guide you for finding eigenvectors also. By the time, settle down with all the tiny results so far we have understood, and so then it will help you to understand the further coming videos. So till then, thank you.